the tele-operated fire suppression mechanism, also called the flame hawk. I am Sharati, this is Vishwesh, Yojit and Pranav, and we are Team Kanya Rasi. So before I tell you about the model, I want to tell you something about us. So before we started to actually work on the model, we all had to learn how to use Arduino. So to be a Kanya Rasi, you need robotics training and you need to have special skills to react to different situations in the correct way. Now, my teammates will tell you more about the model.
Which had to be solved with a lot of brain and all, and the solution had to be effective and resourceful. The problem was fire. I know it sounds dangerous. So it can be a boon and a bane, and when it's a bane, Team Kanya Rasi is here to solve it. And Pranav will continue how it works.
But like how our model came into being, first we had an idea which was to use a servo motor and an IR sensor and attach them together and make the servo motor like spin around 360 degrees, and whenever it would detect fire, it would stop and spray water. But obviously that had drawbacks because it needed like a lot of like extensive complex structures, and also so we made a backup. From that, what we got was we thought to use a sprinkler type of system with the same 360 degrees servo motor like rotating around. But that also the range of which the fire could be detected, and also like IR sensors and the servo motor. So each IR sensor is placed in different directions, and whenever the fire is detected, the servo motor turns the pipe into that direction and the water will be sprayed.
Programming part of our model. What we basically used was everything that was taught to us in the class. We didn't go like, if you see, we started off with initially we started off with if conditional statements, where if we wrote a program where if a IR sensor is detected, then the servo motor would rotate to two more conditional statements, and also use I++ logic for the servo to rotate towards all the directions of the servo. That's everything. And also I important notice, like before we start programming in the Arduino software, since we're using a ESP32 microcontroller, this servo has a different library to which it works with the ESP32. So this is one library that needs to be attached to it.
Problems. Pranav gave us the solution and Yojit told us about the code. So now I'm here to summarize everything and also tell you about the actual physical model. So as Pranav said, we had a very different idea in the starting, but then we modified according to the requirements of like using the equipment which we already have and not making it too complicated. ESP32, the servo motor and the 3 IR sensors and even a pump. So Pranav explained you about how the model actually works, and Yoji talked about the code. So now when we come to the actual physical model of this, we can see that it is a hard sound structure. Basically, we made it with the help of cardboard, and we made a box. And the box has IR sensors on 3 sides. We attached the IR sensors with hot glue, and the connections were also given over here, as you can see. All the connections are inside. The servo motor is attached to the pump, so whenever any IR detects the fire, the servo will turn towards that side, and the pump will also turn towards that side. And one small thing I want to mention, which doesn't look like much but actually plays a big role over here, are these supportive structures. So if these supportive structures weren't there, the pipe was actually bending and wasn't moving the way it was supposed to. So these structures also play a really important role, even though they don't look like much. Bro.
Okay, good.
Testing that this is a quick response model, and like whenever the fire is The pump has to be placed in the water, and the the pump will keep pumping the water and spray it to the side wherever there is a fire and extinguish the fire. So we are open to any questions if you want. This is a pump, and here water will be there. So whenever it senses the fire, it will turn towards that side and extinguish the fire.
Sensor.
Yeah. So whenever this senses, this motor here, it will move towards that side and then
Feedback for this model. So although the team name is Kanya Rasi, nobody is from the Kanya Rasi, I think. Anybody's zodiac is Kanya Rasi? You are? Okay. So that shows like she's the only one participant who is pulling the team. So I really want to appreciate Sharuti in this case because she is the one who was, since the beginning, the team was being built by her. And even I want to specially thank Mr. Yojit also. He supported Sharuti in building or maintaining the coordination between the team members and the other participants as well. They have done their best, and maybe with some more what you say, this some discipline I can call. With that, maybe the team can perform more better. So that's the only one thing which is lacking because since the coordination was not observed much, so that's the only drawback of the team. But the rest, Sharuti has really managed to pull the team into work. So I really want to appreciate Sharuti and Yojit and other members also. Thank you.
We are Team Kinetics, and this is our latest product known as the Nanobot. What is Nanobot? Nanobot is a compact, remotely controlled robotic arm designed for precision handling tasks, housed in a 3D printed acrylic sheets. The project enables smooth and accurate remote maneuvering, allowing the device to lift and place objects with high precision. Next, Lokesh with next Yashwant.
Hi guys, the components which we used in this nanobot are, we used 3 servo motors, one in the floor, one in the elbow, one at the base, and we used servo motor which help us to control with Bluetooth, and the minor components of this nanobot are wires. We used 3.7 voltage lithium batteries, and my friend Lokesh will come.
So next we'll talk about the code. We are given 3 servo motors and ES32 chip and some wiring. So basically we thought to build a complex project, but it's really difficult because with these 3 servo motors we can't make the servo to move all 360 degrees. So we made it in the range of 180, it will move from ear to ear, that's it. So it has a minimal range and it can lift up to 100 grams, 200 grams. And it has some basic accuracy so that you can just put it in a small surface area, not big surface areas. So the code is like we used ES32 for Bluetooth because it's a totally controllable Bluetooth chip. And next we used those 3 servo motors, one at base, one at elbow, one at claw. So the base we use for rotating to go to the position where we want, and the elbow is used for the bending to reach the point where we are going to put the object, and the claw is to control to hold the object. Should you open it or close, the claw will be controlled. Next, the code. So first I thought to make the code by using the normal basic servo motor code, and I used it by including if or if conditions. But then I got to know that the movement was really very fast. It was giving some sudden jerks. So due to this, what I did is I used for loop. Using for loop, it goes in a smoother way. It looks more attractive in this way. And next what I did is I used the reset positions, because when I am turning off the Bluetooth, it should automatically go to the main position where it should be. So I used the reset position for the main position. So using this basic code, I made a good looking, attractive project.
So it has a lifting capacity of 100 to 200 grams, and the key feature is that we are using it to control from the app called Servo BD, and it has the ability to have pinpoint accuracy, and it is controlled through a staff. So using the ESP32, we programmed it. Like this is a normal card, like thermocol sheet, and there are PVC wires we use for connections. In these connections, we also burned ESP32 chip in this process. So we took another one, but this time we planned it carefully First, we started with the servo motors with the connections. Then we went to the power connections with the lithium batteries, and we used a 5 volt voltage regulator for the power regulation.
So in conclusion, our nanobot is a robotic arm which can be remotely operated, and to make this project we've combined basic coding along with 3D printing and electronic components, and with further improvements we're sure that we can create a final product which has more advanced use cases and which can lift heavier loads.
Of the robot, then we will assign on all 3 joints. A simple rotation in each side, and we can move it up and down. And we can close and open the claw as we wish. This is a half distance, and this is completely closed. Now it's a simple demonstration.
Good. Nice, guys. Very good. For the team? Okay. So, as a trainer, I'm just giving a feedback for this team. So, what I have observed is the team is really well disciplined. So, that is the most important thing any teacher or a trainer will look in a student. Because like if you are disciplined, maybe you will have more chances to learn. So I'm not asking like discipline is something like which you need to be silent or something. It is what I'm expecting is simple, like they need to understand the things and they are in the learning mindset. So that's what I call discipline. So all the 5 members, since the day one I have observed, the team is well behaved and they are having good discipline. And especially like the team coordination, like whatever the in charge of the team is there, like he did his best. Like Lokesh and others have performed really good, and they have completely been successful in developing the project. I'm really happy for the team, and I wish you good luck for your next projects and your next career. Thank you.
So greetings to everyone present here. Myself Sparsh. So we are the team Eurekas, and this is a project on intelligent structure monitoring and response bridge system. Well, this is a project which is mainly famous in many other countries like Korea and many other countries which already have the system established. This is the first model which we are actually building for India. It hasn't been yet in India yet. So I am the project strategist for this project, and we have Pranav, who is a technical specialist. We have Janvi and Ravi, who are the architects here, and we have Vishwa, who is the assembly engineer. As a group, we have decided that each and every part should be separated, and thus we have worked towards it. So I'll be explaining you the scientific principle and on what basis this model actually works. So as I told earlier, this is an intelligent structure monitoring and response system. So well, imagine you are on a bridge, and you just, in Final Destination also we have seen that scene where the bridge actually breaks out. Imagine that you're on a bridge and you're going with the car, and suddenly there's a flood going on there. And for some reason, imagine that the water level is above the bridge. The water level is actually above the bridge to this level, and you actually get up and being drowned. So in this situation, it is important that the bridge has to be lifted up. In case of floods, it is very difficult that you have this very expanded structure. It is very difficult that when you try to lift it up, it is quite impossible to do that. So in that case, we need this structure monitoring system so that it actually lifts to avoid any kind of damages. The system is, here we have an Arduino, where obviously we connect all the connections here. We have a battery, which is a power system here. And we also have a water sensor here, which works as an IR sensor. So what happens in the system is, we have a certain level of water sensing here. When the water is above a certain level, the bridge lifts itself up. We have used 2 servo motors on either side of the bridge, and the moment the water is actually sensing, the water sensor is actually sensing the water, the servo motors are lifted from 0 degrees to 90 degrees. In that case, this is an immediate action where the servo motors will lift itself up and the bridge level will also lift itself up. So well, this was the basic part of the project, and now we'll see what the code part of the project is.
Yeah, I'm Pranav. I'm the one who wrote the code.
quite few of them helped me. In the code, we actually use a microcontroller Arduino, which since as soon as the water comes to the water sensor and notices that it's rising to a level where the bridge might go under, so it initiates the servo motors to a degree of 90 so that the bridge gets elevated, and if the water is below it, it comes back to normal using the, you can see it in the the green LED glows up. When the bridge goes a little up, the buzzer gets on, so it gets elevated. Now Ravi and Jan will come and explain the design.
So we are the designing architectures. So we designed the bridge with using ice cream sticks, and we used like at this angle is 45 degrees, and this angle is 180 degrees,
And we use cardboard as a road, and we use iron rods for the support of bridge, and we attach the servo motors either of the iron rods.
next Vishwa will explain.
Any other great project? Our project had quite a lot of problems. Initially, we had an ESP32 instead of Arduino. The ESP32 had way too many connections in it because we were using two LEDs, one buzzer, a water sensor, two servo motors, and a power supply to include. So we couldn't use the ESP32. So we had to switch out the brains of our entire structure to an Arduino to make it work. Then we had issues with stabilizing the bridge, because as I show you now, the entire bridge relies on these two servo motors to rotate it around. We had to stabilize them with two-sided tape and ice cream sticks. Before that, we tried using chopsticks as well. They didn't work. But next, our water sensor did not give readings to the ESP32 which we had before. We had a whole lot of problems before, but as a team, we overcame it with the help of Sir, of course. We couldn't have done it without him and everyone else in our team. That's it.
I explained about the basic functioning, and he told about what are the architects and things to be doing this. And he explained what are the problems we had in this project, which is really important because we had a lot of modification in this project. So before we explain anything else, we would like to show you a demo of this project. We know that we have these two servo motors here. The function of the servo motors is to lift these two sides up. So first thing, we have the water sensor here. Obviously, we need some kind of water so that it senses it. So we're going to switch on the connection right now. We're going to connect the power button to the VIN so that the whole function starts with the power system. And we have water here. So the basic function should be, we have an LED right there so that the people who are there get to know that there's some kind of flooding system. And we'll have a buzzer too when we put the water here. So here I have the water. Well, as you can see, the lift is actually, as you can see, as soon as the water touched the water sensor, the buzzer came and it actually lifted up.
Okay, it was really nice presentation, guys. I like the presentation. Everyone has given their best, and again here also we can see the noticeable women empowerment. The team in charge, or you can say the strategist of the team, Spursh has done excellent job in just keeping the team together, and the other participants also have done their best in assisting her. I have seen the team was always working in building the project and all. Except there are no exceptions actually. There is no except thing. So I really like the team coordination, and good luck for your next projects and your career also. Thank you.
So we VNA are here to present our autonomous surveillance robot here. So basically it's a compact robot which can detect objects and also escape the obstacles. So this presentation we're going to present on how we actually did this model and what was our idea initially and stuff. So English is going to be
So coming to the idea, the spark, which we presented ourselves, or how we've got them, to do this model. So one day when we were observing the ants' instincts, which would escape when we're literally near to it or anywhere. It would instantly or instinctively move away or change its direction or change its path. So then we've finally come with a quote that nature's simplest creatures survive not because of the strength or the willpower they have. They survive because of its instincts which help them adapt and they can live. Yeah, and next the code will be explained by Jyoti.
So we had to modify the code several times. First we had this voltage issue, so we had to modify it several times. So basically this is the code we used if conditions. So basically when the ultrasonic senses the object, which is like if the object is below 20 centimeters, basically the robot will stop and then move backwards and then take a right turn, and then it will start moving forward again. So yeah, this is basically the code we use.
We've used an ultrasonic sensor here and in the front of the vehicle, and below the vehicle we've used 2 DC motors for the rotation of the wheels. We've used an LED here, and there's also a buzzer when it detects obstacles. So we'll be demonstrating it for you right now.
You can just stop it.
So whenever it detects an obstacle, it either stops or takes a right turn. And this basically that one, but it is mostly
There are a few real life applications of the robot. So basically we can use this in godowns where there's a lot of shipments and cargoes coming in and a lot of people working. There are narrow spaces and it's hard to navigate. But this robot is tiny, right? So it can go anywhere, and then it will be easier and more efficient. Another use case scenario would be in disaster prone areas where there's a lot of debris and dust where humans can't go. So this robot can navigate through those areas and tell us where there's a lot of obstructions and how we can navigate through that place. Another one would be something that we all commonly see. It would be a home robot where you clean your house. It uses the same thing to, like, when the furniture or something like that in a way, it could take a different right or a left and then go in a different direction.
And etc. Is there any specific?
The shelves are arranged side to side, where like a man or a people can't usually go through those things. So this can actually be implanted with a camera, which can go through those rows and columns where the spaces are tiny and locate what we need and stuff.
What we need, humans.
Yeah. Like we can ask it, like we can program it in a way where the camera can actually detect what in the shells, what there is in them, and then.
And then it can be used even in the warfares, like maybe to detect.
Yeah, a bigger version.
Yeah, bigger version of it, but no.
No, that's
yeah.
Apart from like these domestic use.
So as I was saying, we are really grateful for this opportunity to be working on robotics.
Even
we
I'm
really
happy.
appreciate your help. Thanks.
We have had so much of conflicts between us, and about the model also. You've helped us right through from the beginning.
Yeah, you're welcome. I'm really happy to train you guys. So I was happy seeing you learning. Okay, let me give you a feedback quickly. So I really like the part where you have taken example from the nature. So that's the really interesting part, because mostly whatever the drones or even the aircrafts which you have seen, that will be taken inspiration from the nature, the birds and insects also. So that's the true inspiration actually. Nature will give us a lot of good inspiration if you are doing something like in a research field also. So I like the coordination with your team. Like the only shortage you have is number of people. Okay, although with limited people you have managed to give a good presentation. So wish you good luck and all the best for whatever the individual and whatever the endeavors you want to achieve in your life. So I'm really happy for the presentation and for your thanks note. So I'm happy. Thank you.
Thank you.
And this is my team, Railbotics. So we're really excited to present to you our project, Railbotics. It's an innovative blend of railways and robotics. It took us a lot of brainstorming and creativity to come
my main role is connecting all the connections here in electronics. I made sure all the connections were strong, safe and secure. Now Naisha is going to continue.
Hey, I'm Naisha. And I'm Santi, and we were in charge of planning and painting the railway tracks. So we wanted our setup to be both visually appealing and functional. So we designed the layout. So we painted it and added finishing details to make our project look more visually appealing.
So as I mentioned earlier, it took us a lot of brainstorming and creativity and work to get to this. So I'm really excited to present the project. Really common thing, right? And they're really tragic. A lot of people die, lives are lost. It just makes everybody sad. So we've come up with a solution. So our model uses an Arduino microcontroller, ESP32, and ultrasonic sensor to detect a change in the distance. And then when it does, it stops the train. So these are the components we used. Yeah, an ESP32 microcontroller, ultrasonic sensor, a motor driver, a buzzer.
Is we have a micro sensor facing downwards to detect the distance between the rail and the distance between the the sensor and the rail. Basically, if the distance between both of them is 3 centimeters or less than 3 centimeters, it's gonna, both the DC motors are gonna work and then it's gonna go forward. If it's more than 3 centimeters, it's gonna stop. That is right there. We have a dent in the project right there. So that's how we're gonna demonstrate that.
No, what is it? We've successfully made it work, and the buzzer alarm works. So yeah, these are the real world impacts. So when it detects faults, it stops it automatically. That it reduces the use for manual stopping. So that will help. That will help us in a lot of ways. Okay, so now we're going to show how it works.
Actually, there is a dent or where there is a break, which is more bench work.
See, let's assume this is a track. It will stop exactly at the edge. So I just wanted to ask the team name actually. Your team name? No, you kept some different name, right?
That was for the fire. This was for the rail.
Okay, Railbotics is the team. So previously this team name was 5 extinguishers. Where is another extinguisher? Absent, okay. Okay, coming to the team, where is the model? That was highlight actually. You just keep it.
Yeah, so when there's a landslide or something, so most of the time it's not visible. So that's why our project would come in handy in those situations.
Okay, I just wanted to appreciate you guys for building such a good, what you said, model, which really have the real trees also. I can see real plants are also included, and the model was really good. The model was actually good. I really like the model very much. That they have built it, all the detailing also, even the stones and all those things, they have just done too much creativity. A fallen tree, a broken track and everything. I like the presentation, the way they have presented. They have created some disaster over here. Like you can see there is some track which has been broken. So I like this creativity in this team. So they are also good. The thing is like they are more creative more than they are in all the spheres. I don't say only in the project, in all the spheres they are very creative. So that's the feedback I just wanted to give. And Avigna also managed, really she literally tried to manage the team, because sometimes the team will put restrictions or what you say, there's a lot of resistance on her. So I have seen that many times. But anyways, she had done best, and the presentation was really good. Thank you.
B, what does B stand for? bold, resilient, energetic.
Animated.
Actually, our other teammate made that name, but he's not present here.
Bold, resilient,
Resilient.
enthusiastic,
Analytical.
Ambitious.
Good afternoon to everybody present here. We are named Bread. All of you know it by now. That is Ritvik, and that is Kailash. We are going to present to you our model today, which is a solar panel, automatic light sensing solar panel. Now all of you are wondering, why is there a Batman logo on your screen? Right? Yeah, Batman logo. Welcome to Gotham City. Batman. How many of you know Batman here? All of you know Batman, right? So Batman goes to save Gotham City at night. He needs power to light his entire house during the day. But he's not going to go save Gotham City during the day, right? He's going to go at night where nobody expects him to come save. That's why we came up with the Bat Cave. Our model is inspired with a situation like Batman's. He needs power to light his house and energize his house during the day. So what he needed, exactly we gave him. An automatic light sensing solar panel which maximizes efficiency to harvest solar energy and store it and light his house. Now this project uses two LDR sensors, one on the back and one on the front. LDR sensors are sensors which capture the solar energy or any light energy and they convert it into signals where the microcontroller can read. And then we used a water sensor so that suppose it's monsoon and Batman is sleeping all day in his house. He's not controlling his solar panel. So when the water sensor automatically detects water, it will go 180 degrees, which we will show you later on. And then when both the sensors are not detecting any light, for example, in a cloudy situation or at night, it will automatically resurface to 180 degrees. Now, the overall objective of this project, I already explained. It's for when you want to capture solar energy using the combination of these three sensors. Now Ritik will explain all the components used and
program called Arduino. Before we were using ESP32, but due to some because we didn't need Bluetooth for our thing, we changed to Arduino for efficiency. Then we have servo motor which helps in the rotating of the solar panel, water sensor for detecting water during rain, and like two LDR sensors for the sunlight, and one buzzer for when it's raining, you know that it's raining and someone can turn it off. Then jumper wire for internal connections. So this is the LDR. This is the where you project the light and it will understand that the light is there. This is the water sensor. So when water is on this, it will send to the microcontroller that water is detected. This is the buzzer. It gives the sound when the water sensor has detected some water. Rating of the solar panel.
Obviously, Batman doesn't know how to code because he's busy saving the city. So, how we coded this is pretty simple. We used analog read for the servo motors using basic for loops. How it works is that it compares if a light is placed on one of the LDR sensors, the solar panel will slowly move towards that towards that LDR, and if it's towards this LDR, it will move towards the other sensor. And if both of them don't sense any light, it will come back to base position again using a for loop. And for the water sensor, we use an if condition. Like if the water is on the water sensor and is being sensed, there will be a high value given out by a digital read condition. And if water is on the sensor, then it will completely become straight, the solar panel. Especially when water is on the solar panel, why we make the solar panel perpendicular to its base position now is because water stagnates, and we can't have Batman get diarrhea or any disease, and he won't be allowed to go and save the city, right? So to prevent these kind of water stagnations and spread diseases, and that's why the solar panel becomes vertical. And another way to use this as an application is we can harvest the water when it's raining. The lead architect of the project who built Batman's cave.
So basically, in Hyderabad, the electricity bills have become very expensive. And even though Batman is like Bruce Wayne is very rich, he wasn't able to pay for his bills. And especially with all the equipment he needs, he's putting all of his money into that. So initially, he had put in a solar panel, which was it only stayed at one place. And after that, it was still not very efficient for him to get enough current to his house. So he reached out to us to make him this basically. This is just a small model of his actual house. It's not his actual house, by the way. We have used a lot of cardboard for this, especially. So all of the working is inside of this box, including all of the wires, and the two sensors are over here, including with the water sensor, which is over here. If water falls over here, it will detect.
How this project works, we need a flash. If you keep it towards there, the solar panel automatically moves towards this exact area of the sun. And if it comes this side, then it will slowly move towards this side. And if both the sensors are not detecting anything, suppose it's cloudy, it will automatically resurface to parallel, so that it will try to collect as much sun as it can, because we do not know the location of the sun. And suppose it's raining, it will become exactly 180 degrees. That is our model.
Excellent. Okay, I just wanted to give you a feedback genuinely that I like the reference where you have took a character from DC, Batman, and made this presentation in a comic way and a funny way. I literally laughed 2 or 3 times by the way you people have presented to this. And my first impression by looking at the model, I was like, there's a meme, right? Try the. It's like that. I was like that actually. To be genuine, I was like that by looking at that what they have built. But when you people have taken the reference like Batman, Batcave, I was convinced, yeah, Batman stuff will be basic and rugged, and I can see that exactly. And who is that much creative to draw that bat logo? I don't know the creativity levels.
Absolute artist.
So it's good actually. It's a very good clean way of presentation, and I like the comic way of explaining the presentation. Yeah, it was really funny, and it was really impressive, the presentation and the model. And I like the presentation, and you can keep this model. I take back my words that I am going to take away the model.
Layman also can understand. That is how you used your explanation.
Guys, all the best for your future and for your career and your projects and whatever it is. I'm really happy to assist every one of you for any programming or any other upgrades. So thank
Be